Hi everybody. So section 5.3 is about graphs of rational functions. And so when we're graphing rational functions, let's look at the procedure here. And I think this is also mentioned in your book, or something equivalent to it is mentioned in your book. So when you're graphing rational functions, remember we saw in the last section 5.2 that rational functions will have vertical asymptotes and horizontal asymptotes and things like that. So remember that basically to find out where the sorry about all the zooming in and out here. So to determine where the vertical asymptotes are, you basically, remember, you factor the numerator and denominator and then basically find out where the bottom is 0 as long as the top isn't 0. And then as far as the so let me turn this off here. Maybe that'll keep it from zooming in and out here. So as far as finding the horizontal asymptote, right, what you basically want to do is divide the numerator and denominator by the highest power of the variable that appears in the denominator, or you can compare the degree of the top to the bottom. If the degree of the top is larger than the degree of the bottom, right, then you'll basically have no horizontal asymptote. If they're the same degree, right, you should have the leading coefficient of the polynomial on top divided by the leading coefficient of the polynomial on the bottom. And then remember, the x-intercepts will essentially be wherever the top of the fraction is 0. The y-intercepts, you find that by making x equal to 0. And then the idea then is you try to take these this information and put it all together to draw the graph. And when you're sketching the graph, it's kind of half art and half science. And so I think on the exam on this stuff, one thing just to let you know is I will give you a certain number of points for doing the procedure, and then a certain number of points for the graph. So if your graph isn't completely right, you should at least get a fair number of points for going through the procedure, and then it'll be sort of subjectively up to me to determine whether your graph looks like the graph or not. But again, your graph doesn't have to be perfect or anything, but let's maybe look at some examples. So let's say, for example, we want to graph this rational function below. So just going through the procedure, the step-by-step procedure that we went through here in this case, right? You don't have to do this in any particular order, but let's see what we want to do first. So in this case, I guess, and there's sort of a step 0 here that I didn't really talk about, and that is you want to factor the numerator and denominator. So you want to factor the numerator and denominator if you can. I guess worst case scenario, if it's a quadratic polynomial on the top and the bottom, right, you could use the quadratic formula, but I think you'll see that most of the problems in the homework are factorable. And so the vertical asymptotes will occur when the denominator is 0. And then what you'd want to do in this case is analyze what's happening to the behavior to the left and right of these to see what's happening with the height of the graph. So for example, you'd want to make a line here for the x-axis and then plot your two 0 points here, -2 and 1, and then see what it does to each factor of the rational function here on either side of those numbers. So like if you pick a number and stick it in for x, like let's say you pick x is equal to -3, as long as you pick any number to the left of -2, it doesn't matter what you pick. But take -3 and stick it in for each one of these factors. And you could plug -3 into the unfactored form here, but I think it's just easier to plug it into the factored form here, because really all you're concerned with is the sign of the rational function, the plus or minus sign. You don't really have to be that concerned about the height of the function at that point. So though you could calculate that, let's just try to figure out the height in this case. So what I'll do is I'll plug a -3 in for the x in each one of these factors and see what I get. So in this case, if I plug -3 in for x and 2x minus 1, I'll get 2 times -3 minus 1, which will give me some negative number. And then I would do the same thing here. If I replace this x with a -3, I'll get -3 plus 4, which is a plus 1. And again, you don't have to worry so much about the 1 part as you do the sign. And then do the same thing on the bottom here, right? Put a negative in for the x here, that'll give you a negative. And then take a negative and put it in for the x here, that will also give you a negative. So what you'll have is you'll have a negative times a positive divided by a negative times a negative, so that should ultimately give you a negative there. So that means that, you know, you have a vertical asymptote, and so the question is the graph going up to infinity like this, or is it going down? Because it's negative, right, it should be going down, right? Then pick some number between -2 and 1, like say x is equal to 0, and stick that in for x and see what it does to all the factors here, right? So if you put 0 in for x and 2x minus 1, you'll get a -1 there. Put 0 in for x here, you'll get a +4. Put 0 in for x here, you'll get a -1. And put 0 in for 2 here, you'll get a +2, right? And so you'll get a negative times a positive divided by a negative times a positive. And that will give you a positive height there. So that means that the graph must be going up on this side. And then do the same thing to the right of -1. And so I think if you pick any number to the right of 2, like say, or to the right of 1, I'm sorry, like say for example x is equal to 2 or x is equal to 3, if you stick those all in for x, you'll get a positive times a positive divided by a positive times a positive. So the height there will be positive on this side, so it should go up on this side. And then also picking some number to the left of 1 here, I guess 0 will work, right? Again, it should be positive. So I don't know exactly what the graph is going to look like here, but it should be going down when you get to this asymptote on this side, up on this side, up on this side, and then up on this side. And normally this will alternate negative, positive, negative, but you can see that doesn't always happen right here. It goes negative, positive, positive. So you'll want to make a sign chart like that. And then you want to look at the other features. So for example, to determine the horizontal asymptotes, either divide each polynomial on the top and the bottom with the highest degree that you have here, which would be x squared, or again, you can just compare the degree of the top to the bottom, right? Since they're of the same degree, it should be 2 over 1, right? So either way you think about that, if you let x get larger and larger, right, all this stuff will become 0, and you'll get 2. So either way, the horizontal asymptote should be 2 there. And then for the x-intercepts, remember that if you have a fraction that's equal to 0, then that will basically be where the top of the fraction is equal to 0. So set the top equal to 0 and solve for that. So that means whatever this graph is, right, it should touch the x-axis at x is equal to 1/2. And then again, at somewhere over here at x is equal to -4. Okay, and then the y-intercept, that's easy. Just make x equal to 0. So take your original equation and stick 0 in everywhere, right? And you should see that you get 2 there. And then just do your best to sketch the graph in this case. So in this case, right, it should look something like this. It should go down on this side, up on this side. Oh, and I guess it should go down over here. I should have tried to pick a number closer to 1 here, because I guess I should have taken into account where the x-intercepts were as well. So it'll go down on this side and up on this side, right? So you can see you've got vertical asymptotes here at -2 and 1, and then the graph does approach height 2 as you go out in either direction here, right? It passes through the x-axis at x is equal to 1/2, and then 4. So I really should have picked a test point in here between -1/2 and 1 as well. So that's kind of what you want to do there. So you can see it's sort of half art and half science, right? The science part is kind of going through those steps where you're doing the calculations, and then you want to do your best once you've sort of gotten all the pieces of the puzzle to put it together. Just to remind you what the steps are again before we do another example. Right? So the steps would be, find the vertical asymptotes, find the horizontal asymptotes, find the x-intercepts, that's basically where x is equal to 0, find the y-intercepts, and then, for part 5, when you're sketching the graph, you might want to do that sign chart. There are other things you could maybe look at too, like you could determine, where like if the graph is symmetric, if it's even or odd. You might also want to plot a couple of points just to see what it looks like. But the whole idea behind this, again, is to be able to sort of graph or visualize the graph of a function approximately without having to plot points. And this is also something that you might do if you go on to calculus. You'll see that in calculus there will be a section where you'll probably do the same thing here, except you'll be adding a little bit more detail to your graph. So if you know how to do this, it should help you when you get to calculus also, for those of you that are going on to calculus anyway. So let's take a look at another example. And again, like I said, you don't necessarily have to do this in any particular order, but I think we'll still do it in the same order here. So in fact, let me maybe just do this one by hand here. So if you look at this particular example, right, so that so the first thing you might want to do is find the vertical asymptotes. Okay, and so the vertical asymptotes, that will occur when the bottom is 0, like as long as the top isn't 0. So take the bottom, set that equal to 0, right? And in most cases these should be factorable, and I think in this case it is. You'll have x plus 4 and x plus 1 is equal to 0. So you'll get x is equal to -4 and x is equal to -1. Right? So keep that in mind. We'll come back and look at these later when we do the sign chart. And then as far as the horizontal asymptote, right, for that, compare the degree of the top to the degree of the bottom. Well, since this is of a lower degree than the top, eventually what will happen is you go further and further out on the x-axis, right? This is going to be getting bigger and bigger. Eventually the bottom will get a lot bigger compared to the top. So as you go further and further out on the x-axis, the height of the function should approach 0. Okay. And then we want to look at the x-intercepts. So that'll basically be where the top is 0. So set 3x equal to 0. You'll get x is equal to 0. And then finally find the y-intercepts if there are any. And that'll happen when you stick 0 in for f. So you'll have f of 0 is equal to 3 times 0 over 0 squared plus 5 times 0 plus 4. Right? So in that case, that'll give you 0 over 4, which also gives you 0. So it turns out that in this case, the x and y intercepts are the same. And then once you've got those, then take your sign chart and make a sign chart wherever the top and bottom are 0, right? So basically, where the bottom is 0, where you have your vertical asymptotes, so at -4 and -1, and then also wherever your x-intercepts are, which is 0, because that's where the height of the function could go from being above the x-axis to below. So let's pick a number on either side here and see what we get. So picking a number to the left of -4 and sticking in for x, the top will be negative. And then the bottom, here's the factored form over here. Right, so if I stick like -5 in for x here, I'll get a negative here, negative there. So I'll get a negative divided by negative times a negative, which will give me a negative. So the height of the function is negative here, which means that the graph should be going down like this. Over here, then pick some number between -4 and -1, like -3, and stick that in for x, all the x's, right? So the top will be negative, this will be positive, and that'll be negative, so you'll have a negative divided by a negative, so the height there will be positive. Pick some number between -1 and 0, like say -1.5. The top will be negative, that'll be positive, so you'll get a negative in there. And then pick some number to the right of 0, right? Any number that you want, 1, 2, 3, 3 million, and stick that in for x. So if you do that, you'll get 4 in here, say for example, or stick 1 in here or whatever you want for x. This will be positive, and both things on the term on the bottom will be positive. You'll get a positive there. So that means that the so wherever you have the asymptotes here, right, it'll be going up on this side, down over here, and then it will pass through the x-axis here and then go up like that. Okay, so so that sign chart will really help you, so I would encourage you to do that. So if you kind of take all the pieces and put them together, right, what's your graph going to look like? Again, it doesn't have to be perfect, but remember, it should go through the x-axis here. And sorry, I guess I should make the x-axis over here, the y-axis, I mean. If you look at it, it should go through the x-axis at x is equal to 0. Now remember, the horizontal asymptote in this case is 0, so once it goes through this point, at some point it's going to come back down and do something like that. Right here at x is equal to -1, you'll have a vertical asymptote. The graph should do something like that. Then in between -4 and -1, right? The graph can't ever cross the x-axis here because there are no intercepts in this region, so it's got to do something kind of like this. Now, as far as how far down this point goes, we aren't going to talk about that in here, but and also where the height, where this point is also, we're not going to worry about that. If you go on and take calculus, you'll see that you'll be able to locate the location of those points relatively easily. But so, if your graph is off a little bit, that's not a big deal. If your graph goes like this and then goes up here and then comes back down, I'm looking at just sort of the basic shape here. And then similarly here, the graph will come up like this, and again, it can't touch the x-axis, and it has to go out here to height 0, so it's going to look something like that. So I don't know exactly what this graph is going to look like, right? But something should look something kind of like that, right? So like I said, it's sort of half art and half science, right? So I will give you a certain number of points for doing this stuff, and then also a certain number of points depending on how close your graph looks to the actual graph. And again, that will be somewhat subjective based on my determination. But if your graph isn't exactly correct, it doesn't necessarily mean that you won't get full credit there, right? Again, if your graph doesn't come down as low as it should, like if it does something like that instead, that should be okay. But if you guys have questions about that and what I'm expecting, let me know, because I know, in a sense, my math lab does not do a very good job of kind of showing you what to do here, because they just have you choose from a certain number of graphs. They'll give you some rational expression like this, some rational function, and they'll just have you pick from A, B, C, or D which graph you think is correct. And on the exam, I may actually have you draw the graph from scratch without a graphing calculator or without any electronic devices at all, so keep that in mind when you're doing those problems. Here's another example, sort of an application. Let's say you want to find the cost of production. So the average cost of production is given by this equation, and you want to find the average cost to produce a certain number of DVDs, where X is the number of DVDs produced, is given by this equation. And again, you might wonder, well, why does the cost to produce a DVD change as you produce more DVDs? Well, so the idea is basically that, maybe the first couple of CDs that you make are prototypes or something, and so their cost might be extraordinarily high. And then, as you become more efficient at manufacturing the DVDs, right, you learn shortcuts, your workers get more productive, then the average cost might settle down to a particular level, right? I mean, the cost probably won't ever go down to 0, but the average cost per CD should go down. So basically what you're doing here is that you can think of the top as the cost of producing X DVDs, and then X is the number of DVDs that you're producing. So you're talking about the average cost, overall divided by the number of DVDs you're producing. And if you think about what the shape of this graph will look like, it kind of makes sense. Again, I don't know if you have to necessarily visualize what it looks like, but you could graph it like we did with the last example here. But in this case, you're not asked to graph it. You're just asked to find the cost of production as X gets larger and larger, right? So in other words, will the cost of production level out to a particular value? And if you think about that, that should happen, probably some non-zero value. So essentially what we're doing here, if you think about it, like I said, you don't have to graph it, but what you're really looking at here is what's happening with the horizontal asymptote. So essentially what you could do is just look at the highest degree term in each, the top and the bottom, right? So they're both of degree 1, so the answer should just be X is equal to 2. I guess another way you could think about this is you could divide each term on the top by X. X divided by X will just give you 2 there. And ask yourself, well, what's going to happen as X keeps getting larger and larger? As X keeps getting larger and larger, 10 divided by a larger and larger number is going to get closer to 0, and the height of this function will get closer to 2. So what that basically means then is that as X gets larger and larger, the average cost of production for each DVD settles down to about $2 per DVD, right? So again, the first couple that you produce may be relatively expensive, but over time, right, it looks like if this equation is correct, you can get the cost down to about $2. So that's sort of an application of this stuff on rational equations. And there are lots of other places where this can be used as well, but there's one example. So what we're going to look at in the next section is polynomial and rational inequalities. So what we're going to basically look at is what we've looked at in the last couple sections, except we're going to replace the equals sign with a greater than sign or less than sign or something like that. So, okay, well, I hope that helped. If you guys have questions or anything, don't be afraid to contact me. All right? Good luck.